Hello 12th standard students, welcome back to chapter 4 inverse trigonometric functions. Today we are going to see the next function. First we have seen sine function and its inverse. Now we are going to see cos function and its inverse, that is cosine. So we know that as the sine function, similarly cos also has a domain with real numbers r and its range is minus 1 comma 1, okay, and range is minus 1 comma 1. I'll directly go into the graph and then we'll see the details. Since we have seen the sine and its a graph and its inverse in a detailed manner, the same way, the same procedure is going to follow here, so nothing unusual here. Okay, here we are starting with 0. Okay, y equal to cos x is your function and you are starting with 0. At 0, when you put cos 0 equal to 1. So the point starts from 1. Okay. So from 1, pi by 6, pi by 4, pi by 3, pi by 2, pi, 3 pi by 2 and then 2 pi. Here is your detailed graph. So from 1 it starts and comes down to pi by 2. So it meets the x-axis at pi by 2. Again goes down at pi, it is minus 1. Okay. And then it comes back at 3 pi by 2, it is 0 here. Here it is 0 and again it comes up and 2 pi it again comes to 1. So this is one cycle or one period. So what is the period here? From 0 to 2 pi, so your period is going to be 2 pi, okay. So similarly we can draw on both the sides, positive side as well as negative side. I have repeated the curves, okay. So from this we see that cos of minus x equal to cos x for all x, that means it is an even function, okay. Since cos of minus x equal to cos x, it is an even function. And properties as you have seen in sine, there is no break or discontinuous in the curve, so it is a continuous function. And the cosine function is even since the graph is symmetric about the y-axis. Here about the y-axis it is symmetrical, this side and this side it is symmetrical, okay. And the maximum value is 1 here. The maximum value occurs at 1 and the minimum value occurs at minus 1, okay. So what are the maximum value where all it occurs? 1 occurs at x is equal to minus 2 pi, 0, 2 pi and 4 pi and so on. Whereas minimum value occurs at minus pi, minus pi, 3 pi. This side if you go, it will go to minus 3 pi, okay. And in other words, minus 1 less than or equal to cos x less than or equal to 1. So remember this. So the cos value lies between minus 1 and plus 1 for all x belongs to real number r. And then coming to amplitude and its period, as we got for cos x, here also you have got y equal to b cos beta x. This modulus b is amplitude and 2 pi by modulus beta is our period, okay. Now when you shift this cos x by 90 degree, that is this curve is shifted towards, so this is shifted by pi by 2, okay. So pi by 2 when you shift, it will come here, that is it's starting from here, isn't it? This curve I am shifting it by pi by 2, so it comes here, okay, like this it comes. And then again it, and next curve, this curve also has to be shifted, so it comes here through pi and then it comes back and then again comes down like this. Sorry, this is not actually done, this is very small, I'll show it here. So when it is shifted, it goes up like this and then comes down the other portion also. When you shift the whole curve, one curve 90 degree towards the right, you will get the sine curve, okay. So cos curve as well as the sine curve are same. So when you are shifting the cos curve by 90 degree, what do you get? Sine x, okay, sorry, this is sine x, okay. So hence we get our formula cos of 90 minus x gives you sine x. This is the proof for that, okay. Now we will compare both the sine curve and the cos curve. Here sine is y equal to a sine alpha x, whereas y equal to b cos beta x, and it lies between minus of modulus a and this side plus modulus a. Similarly here minus of modulus b and plus modulus b. And amplitude we have seen for sine it is modulus a, for cos it is modulus b. And period is 2 by modulus alpha, for cos it is 2 pi by modulus beta. And so we can draw the sine graph in the range from 0 to 2 pi by modulus. This is the period, isn't it? And similar for cos also it is the same, 0 to 2 pi by modulus beta to get one cycle of that graph or one graph, okay. The function, so hence these two are same. The function y equal to a sine resembles both, are having the same almost. a sin alpha x and y equal to b cos beta x are known as the sinusoidal functions. Okay. Now we'll go into our inverse function. The same thing as we have told. So for the inverse function, what will happen? Y-axis will become the x-axis and x-axis will become the y-axis. Here, this is the cos function and this is our cos inverse function, and we have given the points also here. So whatever was in the y-axis has come to the x-axis, and whatever was in the x-axis goes into the y-axis. So 1 minus 1 and 1 comes to the x-axis, whereas the degree goes pi by 2 and the other degrees pi goes to the y-axis. Okay. So the same procedure we are going to repeat. So whenever we talk about the inverse cosine function, we have cos x from 0 to pi to minus 1 to 1, and cos inverse is minus 1 to 1 to 0 to pi. We can also restrict the domain of the cosine function to any one of the intervals. We will get the same and 1 to 1 image only. So restricted domain is called. So this 0 to pi is called the principal domain, and minus 1 and 1 is called as the principal value. So these two only we use when we do our problems. Okay. And so y equal to cos inverse of x only if x equal to cos y for minus 1 less than or equal to 1 and 0 less than y less than or equal to pi. Okay. Cos of cos inverse x equal to x, where modulus x is less than or equal to 1, and in greater than 1 it has no sense because it does not exceed 1. It is always maximum 1. Okay. And cos inverse of cos x equal to x if 0 less than or equal to x less than or equal to pi, and the range of cos inverse at the range of cos inverse. So these 2 points only we will use in our problems when we find out the domain or range or principal value, so on. Okay. So the graph also I have given. So the graph of the function, this graph y equal to cos inverse x is also obtained from the graph of y equal to cos x by interchanging. Yeah, that is the fact. And y equal to cos inverse, the x-intercept is 1 and y-intercept is pi by 2. Okay. So here it is 1 and here it is pi by 2. And the graph is not symmetric with respect to either the origin. So this inverse graph is neither symmetric about the origin, it does not start from the origin, or the y-axis. So this is neither even nor an odd function. So this is a very, very important point you have to remember. Okay. These are the details or the concepts about the cosine and its inverse function. From the next class onwards, we will go into the examples and the problems. Okay. Thank you.